Hello, guys and gals. I'm back. It's good to be back. It's been a while. I've been busy, which is why I haven't done many tutorial videos recently in the last month. I'm going to try to get at least one or two out a month. I'm going to try for two, one on the Arduino and one on the electronics side of things. And as you know, I have two channels on Vimeo. One is for Arduino and one is for electronics, and you can find all my channels on Arduino by going to vimeo.com/electron, which is my Vimeo home, I guess you could say. Okay, let's get to it. Now today, what we're going to do is let me get to SparkFun first. Oh, you may notice I have solved. Whoops. That's what I get for trying to do. You may have noticed I've solved the resolution issue. You're going to see these videos for the Arduino in nice sharp detail. You can tell everything I'll be typing out for the code, so you won't have any problems with that. Of course, they're going to be a little larger, but one of the complaints I got was the resolution on the electronics portions. When we're actually seeing the circuits and the Arduino, the resolution's fine on that. It was the desktop resolution that people were having an issue with. Okay, so a lot of people have been asking me to actually, let's go to where we're going to do an output. You know, we've done plenty of inputs. We've done 3 or 4 inputs from the LDR all the way to, you know, sonic sensor and infrared sensor and even a button. So they want to see some outputs too, so that they could start building things, and I understand that. So what we're going to do is we're going to do an LCD. Now, before we were getting most of our output from our sensors, we were looking at what the sensor numbers were reading. We were looking at that through the serial monitor on the Arduino. But I think for our first output, I think a good output would be to get an LCD monitor up and running. That way we can see, not only do we get our output from our LEDs and our buzzer, but we can actually see what the numbers are while we're working with the sensor instead of jumping back and forth. So I think the LCD is a good fit. And I happen to have this LCD right here. There are less expensive ones. There are more expensive ones. The best thing to know is anything on this page, and this is sparkfun.com. Once again, I don't even get a discount from these guys. If you guys shop here or Adafruit, tell them I sent you, and you know, maybe they can give me a discount. It's telephone in the background, guys. It's a Sunday. So anyways, any of these LCDs that are listed 5 volt, these are the monochrome. And they're character LCDs. So any of these listed as 5 volt, you will be able to use with what we're doing. Like here's a nice red one. And it's the pinouts are the same exact as if we were, the pins we're going to be using are the same for any of these. You may pick up an LCD that doesn't have these 16 pins up top. They may have them laid out in 2 rows of 8 on the sides. You'd still use the same pins, but it's a little more difficult to use on a breadboard. So, which is why I'm choosing this. But you can still use it. Okay, so the first thing we're going to do is open up our data sheet for this guy. It's not much of a data sheet. I noticed the other ones had better data sheets, but this actually looked good. I like this nice, bright, backlit LCD. You'll notice that some of these LCDs, they're not backlit. There's no, backlit. It's just a black on green. So a couple of the pins we're going to use, you may not need, and I'll point them out. You may not need for just a regular LCD, but the one we're going to use, you will. So back to the datasheet. Let's blow this up a little, even though your resolution should be nice and high now. These are our pins, and we're looking at our LCD. It's facing us, And it starts here with pin 1, and then pin 16 is over here. And all the LCDs I've dealt with are like this, pins 1 through 16. We're using the 5-volt model. It's easier to use with the Arduino. So what do we got here? It's a 5 by 8 dot. You know, the dots are in here. 5 volt plus power supply, also available in 3 volt. We'll be using 5 volt. 1/16 duty cycle. This gets a little confusing. Well, I'm going to mention actually what this is. This is just the logic and the LED power. And these are our voltages, our tolerances. And we're actually gonna discuss this for the LED because I'm gonna do something. I'm gonna make a recommendation and then I'm gonna do something totally different. Okay, so we have pin 1, VSS, ground, and I did a little tutorial on these different symbols: VSS, VDD. So if you watched my electronics tutorials, you should know the difference, but they tell you it here anyways. So pin 1 is ground. That's up here. So pin 1 is going to go to ground. Pin 2 is 5 volt. It says plus 5 volts. That doesn't mean you can have over 5 volts. It just means because you can have positive and negative voltage. So that's plus 5 volts for pin 2 there. Pin 3 is the contrast adjustment. So what we're going to do is you can have 5 volts go to that pin, no problem. We're actually going to have a 10K potentiometer so we can adjust the contrast. Once we adjust the contrast, we can replace that with a resistor if we want, instead of using a trim pot in our potentiometer in our project. We have RS. This, now if you notice, now starting it from pin 4 all the way down here to pin 14, you see this H and L, H and L. That's high-low. These are digital pins. So anything, usually when you deal with high-lows, it's usually anything below 2 volts will register low on this, and anything above 2.5 volts will register high. We're actually going to be using 5-volt digital pins on the Arduino. So high will be 5 volts for us and low will be 0. So this particular pin right here, the RS pin, this tells the LCD whether it's going to receive something to display or whether it's going to receive a command, a control command, like move the cursor down 1 line over 3. So this lets it know whether this is high or low. It will show whether it's going to receive data or to display or a command. Read write. Now this tells the LCD whether you're going to read from it or write to it. Now reading is high. Yes, you can actually read the characters on here as well as write to them. We are not going to do that. 99% of your LCD projects you're going to be displaying information. You're not going to read off of it. So basically, we're not going to use an Arduino pin for this. We're actually just going to set this to low, which is write, because that's all we're going to do with this is we're going to write. So we just put that pin to ground, and we won't be using an Arduino pin. So far, we're not using any Arduino pins. This is going to be ground. This is going to be power. This is going to be power to a 10K trim pot. Actually, I'm sorry. This one is going to take up an Arduino pin, RS. E, the enable. This tells the LCD that there's data ready for it to read. So once again, high or low, it tells it whether that there's data that's ready to read. And then we have our communication pins, our data bus lines. And we have 0 through 7. We're actually only going to be using 4 of these. 4, 5, 6, and 7. That's all we're going to be using. We're not going to be using these. Everything I've read from Lady Ada, her site, Adafruit site, to a couple of the other tutorials I've looked at, they all say the only reason to use these is to increase speed. And why use 4 more of your digital pins on your Arduino that you don't have to use. If you need the speed, you can use those pins. We are not going to use them. We are going to use pins 4 through 7. So it starts at 0. So this is 0, 1, 2, 3, 4, 5, 6, 7. So there's 8 data pins. Okay, so we're actually going to be using these. Well, it's not going to let me do it. Okay, we're actually going to be using 4, 5, 6, 7. Okay, now the LCD that we are using actually has an LED backlight. I pointed out earlier where some of them don't actually have an LED backlight. So if you don't have an LED backlight, you either won't have these pins, or these pins won't, you don't need to connect them if they are there. But definitely look at your data sheet. And that's why we're doing this. I want you to be able to understand this LCD. So that, if you have some kind of weird LCD and, it shows you on the data sheet that the RS pin is, pin 7 and this, if you understand what these pins are, you're going to be able to hook up any LCD. Like I said, most of the ones I run into, it's pretty standard like this. So this is what we get. Okay, so let's go back. This is the LCD I'm going to be using for this tutorial, the extra fancy one. And here it is here. Here's a good picture of it. Okay, now, as far as, so we have the data sheet here. We have okay, I thought the data sheet looked a little flimsy. Oh, one thing back on this data sheet that I said I would mention and I hadn't is this guy here. You notice he's 4.2 volts for the LED. And you notice the LED forward voltage here is 4.2 to 4.6. Okay, if you want, you could take a small resistor, maybe 100 ohms, 240 ohms, something like that, and put it in there if you're worried, because we're going to be powering it with 5 volts. Or you could take a diode, and that would kill half a volt on you. I'm actually going to hook it directly up to the 5 volts. I've done this many times before, and I haven't had any issues with it. We're going to redo the automatic plant watering project, and we're going to use an LCD in that. And that I've had running for years, so I'll be able to run one of these LCDs for years and see what happens. But I just thought I should mention that to you, since this is a tutorial and not a... Well, my tutorials are hacking tutorials, basically, anyway. So I just thought I'd mention that for you who are more precise in your projects and want to make sure that everything is perfect. But like I said, what I'm going to do today will work. Okay, so our extended data sheet is here. This gives you, all the ASCII characters, and it gives you the binary code for those ASCII characters. And if you watched I did an electronics tutorial on conversion from hex to dotted decimal to binary. So I'm not going to do it here. But so these are the characters that you can print out. And actually on these LCD LEDs, you can build your own special characters using their, I think it's 5 dots across by 8 dots down. And if I blow this up, you can actually see those little rectangles or squares. See that? You can see the little rectangles or squares. But feel free to go through the data sheet. I'm not going to... I just went through what I felt was the more important stuff. This will actually explain how it's done. So you can actually go through the Arduino library and you can learn... I don't know why you would want to build your own library, but you could write your own program to drive your LEDs instead of using the library. Okay, let's go. Let's get always. Oh, another recommendation I have is when you make a purchase from anywhere of any of these LEDs, LCDs, or any parts you buy, get the data sheet and download it. Because if you go to use this 2 years from now and they're not using this GDM 1602K, which we are going to use today, and they're not using this one, and it's going to be either difficult to find the data sheet or you're going to wind up paying for it. Usually if you search hard enough, you can find it. I've yet to pay for a datasheet. I'll go buy a new part because the part is actually cheaper than what they want to charge for a datasheet before I buy a datasheet. But I always strongly recommend that you download these datasheets and rename them. You know, you could download this one and call it, let's see, do we got electronics? And electronics here. I think I already took it off of here. But you would download it and then name it LCD GM, you know, just so you know what it is. And you can find it in the future. And this one actually came with a label on the back with the part number, ADM1602K. That's another thing I usually do. If I'm not going to use it for a while, I'll put a label on the back of the part if it's not already labeled. And it's just a little paper label, so I don't see a silk screen of the part number on there. Okay, so they'll also, so you get your data sheet, you got your extended data sheet, and then you've got your example. And, you know, it'll come with example code. This is actually, I don't think this is an Arduino, but it's using a library. It's using, you can get these libraries right here. See these .h? These are just C libraries. You can actually run these with Arduino. And text LCD. And this is setting up the pins. We're going to do this. We're not going to use this library. We're going to use the built-in library for the Arduino. But anyways, they have this stuff here, you know, with examples. LCD printf. Ours will be LCD print. There won't be an F there. And you'll see that a lot, a printf a lot in the C code. Now let's just go somewhere else, just because, like I said, these guys don't even give me a discount. So, and if you buy from these guys, like we're going to go to Adafruit.com. If you buy from them, tell them I sent you. Maybe they'll eventually give me a discount. Adafruit's another great place to go. LEDs and LCDs. And she has some here. Some standard ones. This is actually a graphic. We're not doing a graphic today. That's a graphic. Here's a standard one. I think she has the one that I actually have too. That might be it. I'm not sure. Let me click on it. No, it's a little different, but regardless, it still works the same. And she also has detailed step-by-step Arduino plus LCD tutorials. So she'll take you step-by-step through this as well. I'm just doing the video on it because I'm doing the whole series of videos, so I thought I'd do a video on this instead of just pointing you here. But we can go back to the store. And so they have lots of stuff here. They have, you know, lots of electronics. And once again, I'm giving you variety. If you have a person you like to go to DigiKey for your stuff, you like to go to Jameco for your stuff, please go. I don't have any connection with any of these guys. Okay, so I'm going to leave the data sheet. I'm going to close all this stuff. I'm going to grab the data sheet. I'm going to close that. And I'm going to use the data sheet for the build so that I have this. And I'm actually going to use a little sheet that, a little mapping sheet that I'll show you in the video as well. So I'm going to keep this open for now. I guess I could make it a little larger, 125. Here we go. So I'm going to keep this open for now. And cancel that. Okay. Before we get started, what we're going to do is we're going to build out the project first, and then we're going to come back here and program it, and we're going to use some of the program that we already used. But before we do that, this white background is driving me crazy. So both in processing and Arduino, there's a way to switch this around. Now, if you go under Preferences, you can change the size of your font and where all your data and your libraries and everything else is saved. But you can't change this background. You actually have to go to where the program is. So mine is under Downloads, and then under Arduino, And then I'm using Arduino 1.2. I don't know why it's 22. Let me see. I think it's about Arduino. No, it's 0022. I was thinking processing 1.2. I might as well close this. So we go onto here, and then I'm going to search on theme. And there's actually a theme subdirectory. So actually, let's go back here. Let's go Arduino 2.2, and I don't see where the theme is under there. Let me type it in again. Theme. It's not showing me the depth. Okay, well anyways, it's just this little theme.txt right here. If you open up this theme.txt, and I recommend you save as a backup first. I've already backed it up, as well as, you know, I shoot from the hip sometimes. So right here, foreground and background colors. So let's change this. Now this is hexadecimal. This is 6 zeros, this is 6 Fs. When we get into our color coding, you'll see that, so this is the first 00 represents red, green, blue, so that if they're all 0, they're black. And if they're all F, then they're white. But we're just going to switch these two around for now. And then down here we have 000000, and then we save it. File, save. And of course, I've got to open it up. If I already had it open, it would still be white. But now I open it up, and we've got a black background. And if I open up a sketch, one of the sketches we're going to open up, we're actually going to open up 2 sketches. So we'll go to examples, and liquid crystal display, that's what LCD stands for, is that the library is part of the Arduino. So we're going to open up the Hello World. And we're also going to open up our last button sensor, IR sensor. We're going to use the infrared sensor. Close this one. So we're going to modify our infrared sensor sketch. And I'm going to go step by step with you what all this means again, in case you haven't watched the last one. And then the only thing we're going to add to this is instead of the serial print ln, we're going to print to the LCD, and we're going to see the sensor readings on the liquid crystal display. Okay, that said, let's go build it. Hey guys, should probably point that up a little more. Anyways, here we go. We are going to, here's our, okay, with that light on you can't see well. Here is our LCD, and I already put a set of these legs. I didn't show you, but you can get them at Spark Fun. There's a couple of places. Maybe, I don't know if Lady Ada sells them too, but there's a bunch of places online where you can actually get these from. And this allows me to use it in a breadboard or in one of the circuit boards. And so standard. It's a bright. What do they call it? Extra fancy on Spark Fun. So, anyways, that's the first thing you got to do. You have to solder this in there. You can't just, you know, put free floating pins or anything else in there. You've actually got to solder this. At the end of this video, if it's not too long, I'll put, I videotaped myself soldering it, and actually pin 1 came out pretty crappy, but all the rest came out good. That's pin 1 there. So this is our guy here, and I'll put him in the breadboard in a second. The first thing I want to do, though, is, oh, this is another thing I should show you guys. Now this is the sheet I prepared. Now I have the RS pin, which is pin 4 on the LCD, and I'm going to use a Arduino pin 8. So pin 6 to pin 7, and we'll review this as I plug the pins in. And this is just the command that's going to set the pins the way we want it. So the command, which I will show you when we're doing the programming as well, has, you know, the RS pin first, and this is the order they're in. RSEN, and then it goes D4, D5, D6, and D7. So we do in 3, 4, 5, and 6. Now normally I try to keep the pins the same. You know, if we're doing pins on this guy, if we're doing pins 11, 12, 13, 14, I try to use similar pins on the Arduino, but we're actually already using 11 and 12, I believe. And we're actually going to use we're actually going to reuse some of our code from the infrared sensor. So we're going to actually use the infrared sensor again to get our readings. Okay, so what do we have here? Okay, this right here, from hand to hand, is our button code that some of you may have just watched before watching this. Oh, and the battery on the camera is running low, so this is from the button. So this is our complete setup from the button. And the first thing we're going to do is disconnect our button, which I believe is in digital pin 5. And then we have power, and then we have ground, and that's our button. You know, we have the resistor in there. I believe it was a 10K resistor. And so we completely dismantle the button, because we're not going to use that. What we're going to do is we're going to use our infrared sensor. And we're going to hook up an LCD now as well. So this is 3 different potentiometers, by the way. 3 different flavor potentiometers. This is a multi-turn potentiometer. This is actually 500 ohms. This is a 22K single turn potentiometer, and this I believe is this is 100K. This is actually calling for 10K, but we're going to use the 22K in there for the adjustment of the contrast. And once you figure out what it is, you can put a resistor in there. So we're going to adjust it to see what it is perfectly. We're going to read it on using the multimeter here at the top of your screen. And then we could just replace it with the equivalent resistor in a project and keep it that way. We wouldn't be able to adjust the contrast ever again, but you know, it depends. I mean, these are cheap enough. I actually got these in a big package for $9. There was like 100 of them in there, and maybe like 25 of them were actually of a useful range that I could use. Okay, so let's review what we have right now. So what we have right now is we're using pins 9, 10, 11, and 12. We've got the green light going into 9. So it goes digital pin 9 into our breadboard. And then I think it's a 220 ohms resistor I've got in here. You guys want to use a 1K, 640, or 470. 680. 680, 620. Just use a 1K, a 600 range, or a 470. These are much more powerful LEDs. I had mentioned that in previous tutorials. I could even throw 1Ks in here now, and these LEDs would be perfectly fine. They probably wouldn't be as bright, but they'd be perfectly fine. These LEDs could actually take 5 volts directly, so I don't actually need even resistors in for these particular LEDs. These are special ordered LEDs. These aren't, you know, what you're going to find in your parts bin. In your parts bin is generally, it wants 2 volts, 2 to 3 volts tops. So these can take 5, but I've got them, since they're expensive LEDs, so I've got them resisted anyways, at least 220 ohms, so, and they're still very bright with that. So you're going to use 1Ks, you know, use 470s. It depends on your LEDs. Look at the data sheet for the LED. If you're not sure, just put a 1K in there. If it's not bright enough for you, put a 680. If it's still not bright, put a 470. And if it burns out with any of those, you know you use too low a resistance. Okay, so I have my resistor, then it goes to my LED, then to ground. And just to review, remember the long end of the LED goes on the positive side, and the short end goes on the negative. Also, there is a flat portion on the LED where the negative should go. So, pointing towards the resistor is the positive side, and then, which is the long side, and then the short side goes into ground. So we have pin 9 for the green LED. We have pin 10 for the orange or yellow LED. and then pin 11 is going to the resistor for the red LED. So that's our setup here, and it goes through the resistor and then through the LED to ground. And for those of you who want to know, the green is going into row 5, the yellow 14, J5, J14, and J22 respectively for these three. Then the resistors are in F5, F14, and F22 respectively. And then the other side of the resistor is in D5, D14, D22. And then the positive side of the LEDs are in A5, A14, and A22. And then the negative side of the LEDs go into the negative rail. And then I have a ground that goes back over to the ground on the Arduino, which is just to the left of the analog pins, depending on how you're looking at the Arduino. And I'm going to point this out on a picture of the Arduino on the Arduino site as well. So, and then we have pin 12, which goes directly to our buzzer here, which is in J30, and then the positive side of the buzzer is in F30, and then the negative side of the buzzer goes into the negative ground rail. This buzzer, it's not a piezo buzzer. We'd have to pulse it to get sound out of a piezo buzzer. This is a buzzer, which can buzz, I think it goes 3 to 12 volts, so we don't even have a resistor on that, so we're all set for the buzzer. This is the standard output we have been using for all of our inputs. But everybody seems to really like this output, so we're going to keep this, and we're going to add our LCD to it to get our LCD readings as well. So instead of looking at the serial, we're going to print it out to the LCD. And we're going to have it nice. We'll say infrared sensor, and then we'll have the reading underneath it. So this is our current setup. So what I decided to do, now you can use any pins you want on the Arduino, but basically you have to use 1, 2, 3, 4, 5, 6 pins. There's another LCD you can use. It's using SPI, which uses less pins on the Arduino. And we're actually going to have a tutorial on that too. Not today. So today is the most basic one. This is the most basic. The SPI LCDs, liquid crystal displays, these are the ones you're going to find in a parts bin everywhere. You're going to find them at discount places. So that's why I want to do this one first. The SPI is, I don't want to say it's newer, but it's more popular. It's just started becoming popular, so you're not going to see a lot of them out there. And they'll have fewer pins on them. So I want to do this. Anybody can find this in their standard parts bin. If they break apart a piece of equipment, you'll find these in there as well. A piece of equipment with a LCD display, you're more likely to find this than one with the SPI communications. Okay, so, and we're going to use pins 8, 7, actually we're going to use 3, 4, 5, 6, 7, 8. So we're going to use, those are the pins, the digital pins we're going to be using from the Arduino. So I guess let's get to work and start putting this together. So right now I'm going to put my LCD. No, it's in there. Okay, so that's in there now. By the way, these breadboards that I've been buying from different places, they actually snap together to make a bigger breadboard. They also snap apart. The power portions of them will snap off, and they have sticky on the bottom too. But just to let you know that, like, I could snap this off and snap this off and, you know, get rid of a power and have another brick of columns and rows in the middle, which is great. So they're very modular. Okay, so step 1, we have our LCD on our breadboard. Step 2, we need to provide power to this breadboard to use it for our LCD. So I'm going to grab a red, let's get a little longer. I'm going to grab one of my red wires, and I'm going to plug it into the 5-volt power on the Arduino. You notice right next to the analog pins you'll have reset, 3.3 volt, 5 volt, ground, and then you have VIN, which is volt in, which is whatever you're plugging into your Arduino. And actually, I am going to run this whole thing off of a 9-volt battery too. We're actually going to plug it from the computer. So anyways, we're going from the 5-volt here, and then we're going to go to the positive power rail over on the breadboard for our... can I zoom this in a little and keep everything in there? Sorry, if you lose the buzzer, you lose the buzzer. Maybe I can move that up a little bit. Okay. So the only thing, we're pretty much okay. It's pretty much all in there now. Okay, so we went from the 5 volts on the Arduino over to the there's actually only one VIN over there, 2 grounds, to the red or positive rail where our LCD is. Now we're actually going to need a negative as well, so let me get a, see if I have a longer black one as well. That way we can have some separation of this stuff. Okay, now there's 2 grounds in there. So what happens is, if you're reading from left to right, looking down on the board, we have reset, 3.3 volts, 5 volts, which I'm plugged into, ground, ground, and VIN. So the first ground is going to go to the LCD. The second ground is going to our ground for our light and buzzer display. And then I put this into the ground rail over here. Okay, so now we got power to the breadboard portion of our LCD display. And the first thing I'm going to do is supply, looking at my data sheet. Let's see. Pins 1 and 2 and 16 and 17, 15 and 16. Okay, so 1 and 2 is power to our logic. Let's power to our board. And 16 and 17 is power to the backlight. I'm not going to plug in the Arduino yet. So let's take a red and a black. Let's take a couple of reds and a couple of blacks. See if we got some small ones here. It's easier if we just open all this up. Here we go. These are small enough. So pin 1 is in the upper left hand here, and 15 and 16 are over here. So looking at the data sheet, I definitely should have printed this out. We've got pin 1 ground and pin 2 to 5 volts. So let's take the ground first. Pin 1. I'm putting in C22 and then putting into the blue ground rail. Then pin 2, I'm doing a C21 and then into the power rail. And I'll get a close-up of this after it's fully wired as well. Now, you know, that's pin 2 on the LCD. Then we have our backlit. There's an LED backlit in here. So that's pins 15 and 16. And from what I see, it looks like pin 16 is ground, and I'm putting that into C7 and then into, oh, I'm sorry, I'm using a red cable for that, black cable for 16, C7 to the ground rail, and then the positive, keep looking over at that sheet making sure, is 15, pin 15, and that's actually, just so I don't have anything crunched up together, that's actually going to go in A8 to the red positive rail. So right now I have, there's no power to the Arduino yet, but I do have power to, I do have no power to the Arduino, but I have the power hookups to the LED backlight on the LCD and to the circuitry of the LCD. The next thing I want to focus on is the contrast knob. So we're doing all the stuff that we need to do for the LCD first, and then we're going to do our connections to the Arduino. So first we'll deal with all the connections here. Pin 16. Contrast adjustment is 3. Okay, when you look at this trim pot, this little tiny trim pot here, you see there's 3 legs. 2 on either end and 1 in the middle. What I'm going to do is I'm going to have power on one of the ends, ground on the other end, and then I'm going to have the middle one going to pin 3 on the LCD. So it doesn't matter what is what, it doesn't matter which side's positive, which side's negative, but the middle needs to go to the LCD. So we've got A on one end, B, and then C is that middle one right there. So what I'm going to do is I'm going to put that in my breadboard, and most trim pots you do, they'll be straight in a row. This is an odd one that I have where the pin is in the back. So I'm going to put it in, it's going to be in 30, 29, and 28. And my outer pins will be in E, and that inner center pin will be in C. But if you, depending on the trim pot you have, you might just put it all in, you know, row E. And so my A is 28, my C is 29, and my B is 30. So basically one end needs to go to power, 5-volt power. So in A30, I'm going to go, actually let's do A28. No, we'll do A30. A30 I go to the power rail. So A30 I go to the power rail. Then A29, which is the center pin, that actually goes to pin 3. And just to get this a little less crowded, I'm going to put this in 20A. And actually, I'm not going to use a black wire. I'm going to use an orange wire for that. So from 29A over to 20A, which is pin 3 on the LCD. And then I need a ground that goes from 28, and we're going to use 28B just so it's not too crowded in one row, to ground. And re-verify all these connections because you don't want to hurt your LCD. Most of the tutorials have you test one thing at a time. It'll have you test the backlight, and it'll have you test the contrast, and just be very careful with how you do this. And you can do that if you want. You could plug it in. I don't want to keep plugging in and pulling out the Arduino. But actually, if we did that, let's just do it once right now. And if you're watching this video, you know it worked. Okay, I have my backlight on. I don't know if you saw that. The backlight came on there. And if I spin my contrast knob, I get no difference in the contrast. Let me take off this. There's a little cover on that. And I know it called for 10K. It wasn't seated all the way in there is what the problem was. So now you're looking at that. See my contrast knob here? So what you want to do is you only want to see one row. If you see both rows, then it's too much. So I turn the contrast down until I see one row. And there we go. So let me unplug the Arduino right now. So we know our power works. We know we've got our contrast in there. And I'm not going to test. We'll take it out and we'll test the potentiometer after to see what kind of resistor we could put in there, because we could just put in a resistor to that without an issue. Okay. Now we got to hook up our Arduino pins. Now remember, from the top we're going 1, 2, 3, 4. So we're going from the way you're viewing this right now, from left to right. Pin 1 is this corner. 2, 3, 4, 5, 6. So we got to make sure we get these pins right. So how many colors do we have? Yellow. We can use yellow. Yellow, blue. We already used orange. Green. We might have to reuse orange because I don't want to use red or black. So we got green. Hopefully we can find a longer green. Yeah, there's a longer green. And that's too long an orange. That's okay. So for our 4 digital pins, which are going from, you remember my little sheet here? We're actually going from, or actually we've got 4 digital pins, and then we've got 2 of these pins here. And actually I'm going to do 2 of these pins here, which is the RS and enable pin. So let me do these 4 pins first. And so we're going to go from 11 on the LCD, pin 11 on the LCD, to pin 3 on the Arduino. Pin 5 on the, pin 12 on the LCD to pin 4. 13, I know it's showing D6, that's the digital pin, sorry. So pin 11 to 3, the top is the LCD. LCD 11 to Arduino 3, LCD 12 to Arduino 4, LCD 13 to Arduino 5, LCD 14 to Arduino 6. And I guess we'll start with darkest. We'll go blue. And so let's go, that's 15, 14, 15, 14, 13, 12, so 14, 13, 12, 11. So it's in row A12, but it's pin 11 on the LCD. And that's going to go to digital pin 3 over in the Arduino. And then pin 12 on the LCD, which is in A11, but it's pin 12 on the LCD, A11, using the orange cord, is going to go to the Arduino digital pin 4. Then we have 13 on the LCD, which I'm going to put in B10. B10 on the breadboard, but it's pin 13 on the LCD is going to go to 5. Digital pin 5 on the Arduino. And then finally pin 14, which I'm going to put in C9, but it's pin 14 on the LCD is going to digital pin 6 on the Arduino. And we're getting real busy here. I probably should have gotten rid of our old configuration to do this, but you know, with one Arduino we can do a lot. And we're taking up a lot of pins for this LCD. When we go over to the SPI LCD, you'll see it's a lot fewer pins, and we can do even more with our Arduino. So we haven't even hooked up the infrared sensor yet, and we've got pins available for that too. So these Arduinos are capable of doing a lot. And you know, this isn't even a mega. We'd have 54 pins. Okay, so we have 2 more pins that we need to set up on our LCD to Arduino. And that's pin 4 on the LCD to pin 8 on the Arduino, pin 6 on the LCD to pin 7 on the Arduino. I recommend making a little sheet like this. You notice how it says LCD pin and the name. Actually, I have the name and then the pin, and then down here I have the Arduino. So I have this matched up. And I'm going to need this when I write my code, because I'm going to have liquid crystal display. It's going to have 873456 right here, 873456, and that's what pin is controlling what. So actually we do have white, so let's use white. We'll use 2 whites for these. So we're going from, let's see if we get a longer white. There we go. We're going from pin 4 on the LCD, which I'm going to use a 19B on the breadboard, but that is pin 4 on the LCD, and that is going to go to digital pin 8 on the Arduino. Getting a little crowded here. And then pin 6 on the LCD, that's 4, 5, 6, which is, I'm going to put B17 on the breadboard, but it's pin 6 on the LCD is going to go to digital pin 7 on the Arduino. And that's our LCD is hooked up. That's the hookup for our LCD. Now, if things weren't busy enough, you know, if we were just doing the LCD without all this other stuff, it wouldn't look as confusing, messy. Okay, so what I'm going to do with this is I'm going to grab the power off of the breadboard. I'm going to grab the power and the ground off of the LCD breadboard. So I'm going to take a black wire for the ground and bring it over here. In this other breadboard, I'm going to put it in A1. And I should back out just a little so you can see this too. And then bring it up just a little here. Okay. And then I'm going to grab the positive rail and I'm going to put it, actually I'm going to put it in, the negative I'm going to put in E1 and the positive I'm going to put in E2. And then my infrared sensor, I'm putting the red wire, or actually the black wire, I'll put that in A1. And this is stranded wire, so stranded wire is a lot harder to use. That's the infrared sensor, by the way. You should have known it from our last tutorial. The stranded wire is a lot harder to put into the breadboard. That's why I have this little dental pick that assists me in doing that. So I'm going to put this in A1. And it went in. And I'm going to put the red in A2. And I believe for our infrared sensor code, which we're going to reuse, we used analog pin 5, I believe is what we used. And that's what I'm going to plug in here. And that's easy enough to change in the code if it wasn't what we used. And there's our infrared sensor. Now I'm going to back out on this this angle. Take in the whole scope here. And I'm going to take the camera off the tripod and see if we can't get a better look at this stuff. Let's turn on the light here and do a nice close-up. So there's our infrared sensor. This is the breadboard for the infrared sensor, and it's getting its power. It's getting its power from the LED breadboard. See, we're powering these two rails here. And then we're grabbing the power off of that as well. And the Arduino, we should have enough power to do that. Here's our Arduino mess. And like I had pointed out earlier, these are the analog pins. These are the power pins. Slowly go over that so you can see. And these are all our digital pins up here. And I mean, they are a mess right now, but I managed to separate. You know, I have the LCD from, I believe, 9 going down, and then 10, 11, 12, or 9, 10, 11, 12, from 8 going down, and then 9, 10, 11, 12 is for this guy over here with, once again, the buzzer. So, but actually, let's take a close look at, that's the LCD upside down. And there's the little potentiometer. And after we get this up and running, we'll take out that potentiometer and see what we can replace it with, just a resistor. And of course, it doesn't stay in there very well, that potentiometer. And that's just for contrast. So this is our LCD. So now our future projects, when we do input and output, even when we do our plant watering and our Ethernet and our wireless, now we can have it read on the LCD instead of having to go to the serial. We'll still use the serial port, but we can use the LCD as well, which is just a nice way to do things. Okay, let's go hack our code. Okay, now we're resuming. I think we're recording. Yep, see that little blink, 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 blink? Oh, this is going to be a long one, huh? 22 minutes of lecture alone. Okay, so, as you can see, I was using the sheet. I had to look at the sheet. And, I don't think we're going to need the sheet now, but I'm just going to put that down for right now. Okay, this is our liquid crystal display. Now this one we got from our example library. So if we go in here, we say examples, we see there's all kinds of code in here, guys. You gotta, even if I'm not getting a video out, get in here and experiment. We've got Ethernet stuff, liquid crystal, matrices. Matrices are nice to deal with. Servos, SPI, there's that SPI I was talking about, which we're going to get into as well. But there's just so much, from basics, blinking LEDs, to analogs and sensors and all kinds of different stuff to play with. Anyways, we're dealing with the liquid crystal display. Now this is a built-in library. Some libraries will actually have to add, like we'll say import a library, and like an SPI library or something. And all it does when you import a library, all it does is puts that include statement in. But we don't need that. So I believe the LCD is part of the core. Problem resolved. Okay, that's what you get for the unscripted. Oh, I'm sorry, there is. I guess we do have to include it. So I didn't notice that. One way to import a library is just to go, yeah, it is there. So, by the way, if I was up here, I could do Tools, Sketch, Input Library, Liquid Crystal, and boom, there it is. It's already included down here. And that's it. You can type it in yourself. So, that doesn't make a difference. Okay, now, our thing is if we want to test with this, which is what we want to do first. We want to take a little test with this first. We've got to tell it what pins we're using, because its default pins, if you notice, we were already using pin 11 and 12, which is why I didn't want to just use the default pins for this. So from that little sheet, ours is actually 8. 8 is for the RS. 7 for our enable pin. Oh, there was one thing I left out on the... we'll have to do that. I have to ground a pin. Digital 4 is 3. D5 is 4. D6 is 5. And D7 is 6. Okay, now I'm going to go back to the video for a second. So let me pause. Okay, actually, don't let me pause. Let me show you. Let me show you first what I left out. See this read-write guy? Pin 5 has to go to ground. Pin 5 has to go to ground. So let me pause this for a second. Sorry guys, this is what happens when we're unscripted. And pin 5 has to go to ground. Without pin 5 to ground, the LCD might not work. Pin 5, if you remember, that is the read-write pin. So we've got 1, 2, 3, 4. Pin 5 needs to go to ground. And having it pulled low tells it that we are going to write to this and not read to it. So I'm going to stop this recording and change the battery. So I added one in there. So I apologize for that. I forgot it. It was a critical pin, but like I said, unscripted. But I caught it before we figured out it didn't work. So back to the desktop. Okay, guys. Glad I caught that before. Make sure we didn't interrupt any coding. Okay, glad I caught that before we tried it and it didn't work. So this guy, pin 5, he needs to go just straight to ground because we're not going to read from the LED. We're just going to LCD. We're just going to write to it.